The working principle of magnetic beads. A magnetic bead is an energy-consuming element that can dissipate signals with relatively high frequencies in the form of heat and retain signals with relatively low frequencies. Commonly used magnetic beads include those with plugs and those sliced as shown below. Let's take a look at the working principle of magnetic beads. The structure of a magnetic bead can be simply viewed as a wire passing through a magnetic material made of ferrite. When current flows through the wire, a circular magnetic field around the wire will be generated, which will magnetize the ferrite material of the magnetic bead and produce a stronger magnetic field on the ferrite. When the current flowing through the wire changes, the magnetic field strength of the ferrite will also change. According to the law of electromagnetic induction, a changing magnetic field will generate an electric field. At this time, a circular electric field will be generated on the cross-section of the ferrite in the magnetic bead, which will further generate a circular current, causing heat to be generated on the ferrite and causing losses. This kind of loss is called eddy current loss. When the signal frequency on the magnetic bead is relatively low, the current flowing through the magnetic bead changes slowly, and the magnetic field also changes slowly, so the induced electric field generated on the ferrite is relatively small, thus the loss is relatively small, and the magnetic bead has no significant effect on low-frequency signals. When the signal frequency on the magnetic bead is relatively high, the current flowing through the magnetic bead changes quickly, and the magnetic field also changes quickly, so the induced electric field generated on the ferrite is relatively large, thus the loss is relatively large, and the magnetic bead has a significant absorption or obstruction effect on high-frequency signals. This is why magnetic beads can absorb high-frequency interference.